How many of you are backend developers? Some people are the same, also about 1/3. And I guess the rest is just full stack, right? So I've heard that front-end developers don't really want to worry about how backends are implemented. They just want to use it to provide the best user experience for the lab, for the app that the users want to use. And this talk will be about building applications without servers. My name is Marek. I'm a software engineer in Google Cloud Functions team in Warsaw, here in Poland. And I daily work on building the Cloud Functions product. I also worked with Jarek. Jarek was actually the person, Jarek who gave the keynote at the very morning. He was the person that actually started the project in Warsaw. So our office, for those who don't know, is right in the center, close to the Palace of Culture and Science, and this is the view from our balcony. So far this was about me, but this talk will not be about me. This talk will be about Frank. That's Frank. Say hi to Frank. All right. So Frank wants to build a messaging app. He's a, let's say, front-end developer, but he has a lot of experience in the backend as well. He wants to build a messaging app. He just realized that all the messaging apps that are on the market don't really satisfy his own needs. He wants to build something better, more useful. He wants to attract more users. He wants his app to be successful. He's been thinking a while on a good name, and he came up with the name Hipster Chat. And so the next step is, how does one build a messaging app? I see some people know from the audience, but let me not let you answer, but let me just show you what Frank realized. So Frank is an experienced engineer, and he knows that, first of all, chat applications are nowadays on mobile phones, so he needs mobile clients, but probably also web clients. Then there must be a server that will take the messages that users send to each other and then push the messages to the other clients that share the same chat room. And finally, there must be some database where the messages that are not currently, for users that are not currently online, can be stored so that when the users join later the chat room, they hit all the log of the messages. So yes, we have front ends, we have the server, the backend, and also a database. And of course, the server and the database have to be highly available in case something breaks. There should be redundant parts in the system that will just take over. Of course, Frank knows that Google is pretty great at messaging apps. We have really a lot of them. We have Allo, Duo, Hangouts, Messages. There used to be a Gmail chat as well, Google+, and so on. So Frank thinks that they must have good tools to build chat applications. So Frank has been researching a while, and he realized that actually he doesn't have to buy servers. He can use virtual machines on Compute Edge. And I think this is a choice that all of you would go for. Very easy. Buying servers costs a lot. You have to give the money up front. You have to maintain those servers. If a disk breaks, you have to just fix it. And of course, you have to have many servers. If one gets broken, the other one has to still serve traffic. So with virtual machines, all these problems go away. This is really great. And of course, Google has been a while in the industry of managing servers. We've been managing it for quite a while now. We have hundreds of thousands of machines all over the world. And this is another reason why it doesn't really make sense to buy physical servers, to put them somewhere in your server room. It's better just to rent virtual machines. But virtual machines are still expensive. It's not that all the costs go away. Even though you don't have to manage the hardware, you still need to manage the software that is on the machines. And Of course, you have to have many virtual machines running at the same time. If one gets broken, if the software breaks down, there should be another one for high availability. So this costs. Also, servers cost even if there is no user traffic. So if the chat application, let's say, you don't have users that chat at night at the beginning, and on the early phase of when you just launch the application to users, you realize, I don't have users at night. Maybe I should shut down my servers. Do you think that's a good idea? Well, of course not, because if somebody eventually tries to chat at night, then it will not work. So they will just use a different chat application. So virtual servers cost because they have to be available even if users don't use it. So you pay for the time for the virtual machine. And also, a virtual machine can scale to the traffic that you have, but you have to have some reserves. For instance, the docs say that the good auto-scaling target is 75% of the CPU utilization, so about 33%. You have to pay additional 33% of the cost just to have this spare capacity in case some things go good and you have more users. You have a spike in the usage. And finally, Frank needs to manage the software that is running on the servers, the operating system with patches, upgrades, also the web server that handles the load from the clients, and so on. But luckily, Frank doesn't stop here. He still looks at what other services Google has, and he finds about Firebase. How many of you have heard about Firebase? That's really a lot. So I'm afraid this will be a very basic talk, so I apologize for that. I hope to put some more advanced things at the end if we have some more time, but I hope you will still learn something about functions and serverless. All right, so Frank finds about Firebase, and he knows that Firebase has a few backend products which he can use directly, which is authentication, real-time database, and the storage. And in particular, the real-time database is very useful for chat applications the chat application that Frank is building. Because Frank says that with real-time database, I don't need servers to deliver chat messages to my apps. And Firebase actually does it for him. Firebase real-time database works in such a way that it synchronizes all the clients that are connected to the database at the given time. So when one mobile client, sends a message to a given chat room, then other clients that listen to notifications to that chat room will get a notification that there is a new message, and they will be able to automatically present that to users. So with Firebase, you can build chat applications even without servers. This is a kind of serverless, but I've heard concerns that Google has a bit different definition of serverless than the rest of the industry. So even though this is a bit serverless, I would not call it serverless because there's no code that Frank writes that runs without servers. So this is just a service that allows you to build your applications without backends. Firebase serves as the backend, as a mobile backend. And also the other services are useful. With Firebase authentication, Firebase authentication can manage auth for the users, and the client apps can upload pictures or videos to cloud storage directly so that the other users from the same chat room can download it if they have permissions. So the new architecture looks like this. We have mobile clients. We don't have any servers. We have Firebase real-time database that manages the chat messages that go into every chat room. And we have cloud storage for storing media content. And of course, both of them are highly available because this is what Google provides by default. But this is not enough for the application that Frank is building. Frank wants more services. For instance, Frank wants to resize images when they are uploaded so that the other people in the chat room don't have to download megabytes of data, but maybe just half a megabyte. that would be really great. So these are some things that are very difficult to build without custom servers. And for these resizing images, Frank could just put a custom backend in the middle. So users will, the clients will actually upload those pictures to this custom backend, which will take care of scaling it and writing to the storage so that it can be accessed by other clients. But even though with this custom backend, we get thumbnailing pretty easily because it's quite easy to write such custom backend. We lose all the things that I mentioned before, that servers were actually expensive. But also we lose the services that Google Cloud Storage provides for free, which is resumable uploads and downloads. We also lose the end-user authentication. We have to build it on our servers from scratch. And there is no pay-as-you-go. So if there is no usage, Frank still has to pay for the servers that are running. And finally, global scale. Frank would have to set up many servers to have this at global scale with fault tolerance and so on. But luckily, instead of setting up a custom backend, Frank can use Cloud Functions for Firebase. And Cloud Functions for Firebase complement the previous picture about real-time syncing of the database. You can think about a Cloud Function as yet another client, but it's not really a client, it's a part of our server-side code. So in the same way, as users get notifications about that something happened in the chat room, this Cloud Function can also get such notifications. And this Cloud Function is written by Frank. So this Cloud Function can do multiple things on the messages that arrive at the database. For instance, they can scale images that are written to storage somewhere. They can filter offensive language from messages and so on. So how do Cloud Functions work at the end? When there is an event emitted somewhere in the cloud, what I showed you before were events emitted from the database, but we also have events emitted from the storage, and I will tell you more about events in a minute. So when the event is emitted, the function is triggered, and the function is source code that you write. So this is your code. This is the server part of your service, of your app. And then the code gets executed. And the new architecture is similar to the previous one, but now we also have Cloud Functions on the very right. And those Cloud Functions get automatically triggered to process the data that arrives at the database or in cloud storage. And of course, everything is highly available. Frank doesn't have to worry about servers and how to set things up. So a summary for now is that Cloud Functions let you extend and connect Firebase and cloud products with code. I've mentioned here Cloud Functions for Firebase and Cloud Functions. Please remember that these are the same products. It's just different view of the same thing. So Cloud Functions for Firebase is a standalone cloud product, but Firebase has additional tools, deployment tools, and additional integration that makes building Firebase applications with Cloud Functions very easy. Cloud Functions may have multiple types. I've already mentioned the real-time database and Firebase real-time database and cloud storage. But there could be also Cloud PubSub, which is a messaging queue system in the Google Cloud. And the most interestingly, there can be HTTPS functions. So you can deploy a function that will be triggered when somebody hits an HTTPS endpoint or HTTP endpoint. And that opens a long list of possibilities to integrate functions with other services. For instance, using webhooks. For instance, you can process payments with Stripe. When there is a payment event, Stripe will call your webhook, and you can do something. You can register a cloud function and do something. You can integrate with Google Assistant. You can build chatbots on Google Assistant using Cloud Functions, using webhooks as well. You can even integrate with Nest thermostat. This is what I heard. I've never tried. So just to remind you, these are the use cases that Frank was thinking about that forced Frank to build some server side of his app, but that server side was serverless, was on Cloud Functions. So filtering offensive messages is pretty easy. Those messages are written to real-time database in some place that is not accessible to other users yet. Cloud Functions get a notification that something new was written. The Cloud Function, when it's called on that notification, it knows it has access to the data, to the database, and it has access to the event, the new data that was added. So this Cloud Function can call some APIs to filter these offensive messages and then write the messages back to the place where other members of the chat room can access it. The other use case, resizing images, is pretty easy. The app writes, as before, images directly to cloud storage, but when an image is written, a cloud function is automatically triggered. You can resize the pictures and store it again. And this all makes Frank really happy. He doesn't have to think about servers. Everything just works out of the box. So all these things Frank was able to do completely serverless, even though the servers are somewhere underneath. The principles of serverless, this is something that was related to the questions we've had in the morning. So first of all, it has to be, the infrastructure underneath should be invisible for users. Even though there are servers underneath, users like Frank don't care, they just write code. It should be auto-scalable. If there is more traffic, those functions would be called in parallel machines, instances, cloud provider. And most importantly, there should be no payment for unused CPU cycles. So users should pay only, users like Frank, not the end users. Cloud customers should pay only for the cycles that the function used for execution. So in case of Cloud Functions or Google Cloud Functions, we charge users in 100 milliseconds increments. Whenever a function is called, it takes some time to execute, and this time is rounded to 100 milliseconds. Charge the users for. So if a function runs for 1 second, it's very cheap. As I mentioned, even though it seems that serverless means there are no servers, the servers are still managed by Google. To go a little bit more deeper into how things work, let's assume that we have a function, this black box here, that is serving. And when a new request arrives, this should be directed to some instance that can actually execute the code. We call it instances. This you can think about it as containers. And normally, there may be some instances that already serve some traffic, but if there is no instance, the infrastructure Google will spin a new instance, and this is called a cold start. So when there is no instance serving the current function, there is cold start, and this cold start is a little bit more expensive in the sense that it takes longer. And what happens during the cold start? During the cold start, we set up a new container where the function source code can be loaded. We start the Node.js interpreter. Functions are mainly using Node.js, although other languages are available. And then the user code is loaded, and finally it's executed. So on this cold start, when we do it for the first time, we need to load the source code, start Node.js, load the source code. But on subsequent function calls, this install will be already there. So it will be faster. And of course, serverless, as I said, users pay only for the time where the function is used. And when the function is not used, it's very important for the cloud provider, for us, to minimize the costs. And if a function wasn't called for quite some time, we will just shut down an unused instance. So if a function is not used for well, it very depends for how long, but for some time, the instance will be deleted, and then subsequent function calls will result in cold starts. You have to also keep in mind that if your function scales up, if you have a lot of traffic, Cloud will automatically set up new instances that will serve the traffic. And that will also result in some cold starts. But the existing instances will be still serving the same function. This is an example of a hello world in Cloud Functions. As you can see, this is 3 lines of code, as in any other language, probably. You can deploy it to the cloud and then just call the HTTP endpoint, in this case using the web browser. And with just those 3 lines of code, you get automatically an SSL certificate, a fully qualified domain name under cloudfunctions.net. This function is auto-scaled, and you get billed for a sub-second, for 100 to 100 milliseconds intervals. You can deploy such functions using Cloud Console, the UI for Cloud, or you can just use the command line. It's also possible to use the API Explorer. It's a wrapper on top of the API directly, so you can use the API directly. And also there is Firebase CLI and Firebase Console, which can also be used to deploy functions. Now it's time for a short demo. I set up a phone number where you can text a message, and those messages will be then stored in the database. So be careful what you write, and I may show it to everyone. And the system built on top of Cloud Functions will analyze whether those messages are positive or negative, and then reply to this phone number. Please don't put Polish characters, because I think it doesn't work very well. I wrote it very quickly, so I think encoding is not completely correct. So yes, so to summarize how this works. You type a text message. This goes to Twilio. Twilio is a system where you can have a phone number registered, which will receive text messages and also phone calls. But here, these are the text messages. Twilio allows you to set up a webhook, HTTP webhook, that will receive the content of the text message. Then the function will call Natural Language Processing API to determine whether this is a positive message or maybe not so positive. There will be a score. And finally, we will store the results to BigQuery because we want to analyze them further. And of course, we will reply directly to you. So has anybody tried sending a text message to this number? Did you get a reply? Okay, some of you may get some errors, of course, because this is a very simple function without any retries, but sometimes things don't work. So that's expected. And we can check what we have in BigQuery. So I've been playing with that yesterday morning, and I already sent about 50 messages. Unfortunately, I cannot. Okay, so I've tried with Polish as well. It seems like it didn't work. But on the other hand, Ale Super was correct. The determined to be good. I think this is these one are the most recent. Anybody sees their own messages somewhere? Very good. Let me show the function, because that's really interesting. Because the function is actually, I have 3 functions in my project. So let me go to the one for text messages. And let me show you the source code. Let me click here. I think that's almost visible with this font size. So we have some require statements at the top, which I will just skip. And the function body is, well, almost only this. So what we do here is just to receive in the request, we'll create a new document out of the body of this text message. Then we will send it to natural language processing to detect sentiment, positive or not, the score. And finally, when we get the results, we'll just store it in BigQuery. And that's basically it. The rest is just error handling. Oh, yeah, sorry. And we send the response. So to send the response, this is the format that Twilio expects from the response, to send that as a response to the user. And that's it. Very simple. Let's go back to the presentation. Another example, this is very similar to what Frank did in the hipster chat. We have a picture uploaded to cloud storage. When that gets uploaded, a function is triggered. And we use Cloud Vision API to detect what's in the picture. And that will tell us whether this is a cat or a dog. So what do you think, is the cat or a dog? So this is actually neither a cat nor a dog. It's a raccoon. And this is what Cloud Vision API would give me if I upload this. But I will do something different. I will not upload this picture because that is boring. I'll just actually take a picture of myself here, and let's see what Vision API says. Where do you want me to take a picture, or what would you like me to include in the picture? Right. It's hard to include the entire dev fest, but it's a part of it. Okay. I think I just snapped a picture. I use Google Photos, so this should automatically get uploaded to my Google Photos account here. If I reload. Okay, I can see it on my phone. Let's try again. Says that my phone says that the backup has just been finished. Let's try again. All right, so that's me. So I'm going to click here. There should be somewhere to download it, maybe here, download. That starts with IMG, the date. Let's go to cloud storage now. So maybe let's go to Google Cloud Functions, because I already have the function deployed here. I actually have, well, the demo will be more complicated. Let me maybe go back to the slides. The demo will be slightly more advanced, because that will include actually two functions. One will be generating a thumbnail, so that's the use case that Frank had, and the other one will be passing the picture to Cloud Vision API. And two functions are registered on the same cloud storage bucket, so they will be both triggered when a new file appears. And the demo, by the way, is available on GitHub. It's bit.ly/gcf-resize. Okay. Functions, there is this function create thumbnail. When we click on trigger, we can see the bucket that is used as the trigger. If we go to that bucket, we see that it's empty. Let's try to upload files. That should be this one, hopefully. And now it's being uploaded. Okay. I haven't used my functions for quite some time, so that will probably result in a cold start, which will mean that there's additional maybe 2 seconds of latency. And the results should be stored in another bucket, which is called Biskup demo out. I think I messed it up because I should have shown you that this was empty a second ago, so you have to trust me, this was empty a second ago. Oh yeah, time. So let's see first maybe on the thumbnail. Is it really smaller? Yes, it is smaller. Very good. And now the most scary part, what is in the picture? I'm always curious. Facial hair. It's not much actually. I'm quite surprised. So usually Cloud Vision API gives me a long list, maybe of 10 items, and each of the items has some score. In this case, well, it's pretty poor result, just facial hair, but maybe that's fine. All right. Thank you. Maybe when we are here at the demos, I can show you also that functions may give you, if I find functions, so let me go back to functions. I had those three functions. So in functions, you can see some telemetry, whether those functions are used or, so maybe let me show you. So this is the function that was handling text messages, and you can see that just now during the talk there was some spike in the usage. So these were your messages. So the function was executed. We can also see these are invocations. You can also see how long the execution time was. So that was about 300 to 500 milliseconds. These are percentiles. The blue line is the P90, 19th percentile, and the others are 99 and 95. You can also see the memory usage. Sometimes if your function uses too much memory, you have to increase the instance size so that there is more memory and your function doesn't crash. So the memory usage was pretty low. The default size is 256 megabytes. So that's enough. All right, let's go back to the presentation. So what I just showed you is that, I didn't show you logging, but I showed you some monitoring that we can see what's going on in our execution environment. So normally when you have servers, it's pretty easy to debug it because you can just log into the server, you can just see multiple logs. Things get more complicated if you have distributed set of servers because you don't know which server actually you want to debug. But with Cloud Functions, things are even more complicated because you don't have access to those servers. You only have the functions that are being executed. So all the telemetry, all these debugging tools have to be provided by the cloud provider. And Google Cloud actually does it in the form of Stackdriver services, including logging, monitoring, but there's also error reporting, tracing, debugging, I think. Right.